Hello, this is Dr. John, your physics and math professor, here to work on another trig identity with you. I've written it up on the board here. Cosine 2 theta over sine theta is equal to cotangent squared theta minus 1 over cosecant theta. In this case here, what we have is on the left-hand side, and the right-hand side, both of them have some oddities to them. This one has a squared function. This one has a double angle formula. So we'll probably need to work on both sides in a parallel fashion, see if we can come up with the same thing, because then we could work backwards one way or the other. So if we can work this down to something, and this down to something, and this here is the same as this, well then we could just work backwards from one to the other. So that's just as good as a proof of taking one side and making the other with it. So on this side over here, we have cosine 2 theta. If you remember the cosine double angle, and these are a couple of the principles we're going to use. Trig definitions, double angle, Pythagoras, and difference of squares. We may not use them all for each identity, but we'll use a couple of them for this one. Here we have the double angle of cosine. If you remember that one has cosine squared, or it has sine squared, or it has both sine and cosine squared. But because we have a sine in the bottom here, let's use the one that has the sine on the top. So cosine 2x is equal to 1 minus 2 sine squared x. That's the double angle definition. I just happen to have it memorized because I've done it a bunch of times. Let's take this, plug this in here for the left hand side. So this here, all of this would replace all of this up here. And then it's all going to be over sine theta. So it's going to be 1 minus 2 sine squared theta. Just replace this over sine theta. This over this, since we have a common denominator, this over this, 1 over sine theta minus 2 sine theta. One of these signs cancels here and we're left with a 2. This, of course, on the left side is cosecant, and this on the right side we're going to leave like this. So I'm going to take this answer here and write it up here underneath here so we have that handy. Erase a couple of these things here and put this answer under here. So this is going to be cosecant theta, that's this term, minus 2 sine theta. That's the left-hand side. Now let's work on the right-hand side. This seems to be pretty simple already. Let's look at the right-hand side here and see what we can get from that. We have here a squared function. This looks like, because it's a squared function of a cotangent minus 1. If you're familiar with it, if you've done this a couple of times, you'll realize that looks sort of like the Pythagoras' theorem. Pythagoras' theorem for triangles goes like this. Sine squared plus cos squared equals 1. But there's other variations on that as well. There's variations where you can divide both sides by sine, or divide both sides by cosine. Since we're going to want the cotangent function, cotangent is cosine over sine, so let's try dividing everything by sine squared. This here is going to be 1 plus, this is cotangent squared theta, and this is equal to cosecant squared, 1 over sine squared. So this thing up here, we could take this and change this format here. Cotangent squared would be equal to cosecant squared minus 1. This is just simply another variation on Pythagoras' theorem for triangles. You don't need to know all of these. All you need to know is sine squared plus cos squared equals 1, and then find other ones by dividing by sine, dividing by cosine, sine squared and cosine squared. So now that we have this here, let's take this and plug this in for here and see what happens. I'm going to make myself some room here and change colors just so you can see the difference. All right, here we have cotangent squared, so I'm going to write this in there instead. I'm going to write cosecant squared theta minus 1. That's this here is the same as this here. The pink here becomes the pink here becomes the pink here. I've rewritten it here. And all that is minus 1. We don't need to put big brackets in here because we're just having one thing that we're subtracting. So minus 1 and minus 1 becomes minus 2. And all of this is over cosecant theta. Now we see, we have something over the same denominator. Let's break those up into individual terms. This first term would be, I'll do this over here, cosecant theta, because this would cancel with this, leaving us 1, minus 2 over cosecant theta. Here we have a cosecant theta, just like we have here, and here we have minus 2 sine theta, because 1 over cosecant theta is this. So this first term is this second term is this. We've just proved this trig identity. If this was helpful, like this video, and we will see you in the next one. Bye-bye.